So, dear authors, it is my pleasure and Marcin's pleasure to welcome you at the 6th webinar organized by Philosophical Education Journal. The webinars that we organize are always dedicated to the upcoming issues of our journal, during which the authors are presenting the ideas expressed in their articles to the broader audience and sometimes can answer questions of other authors, of editors, of participants of the webinars. So this is one of them. We have been talking at first webinars, we have been talking about the issue about Lvov-Warsaw Philosophical School, but now this is the second webinar devoted to the issue about the ethics of artificial intelligence agency. And this issue is being prepared with an international group of issue editors, Professor Andrea Vestrucci from University of Bamberg, Germany, Professor Sara Lumbreras, University of Comillas, Spain, and Professor Ralph Weir from University of Lincoln and University of Oxford, I believe, who have drafted call for papers. In our issue, we wanted to deal with all the controversies that are connected with the rise of AI. We are aware of the fact we have been just 2 weeks ago, we have been recording another promotional video with Marcin Trepczyński. This video will be published soon about the answer to the question, why should we create an issue about AI when so many publications are already being prepared, published about this issue? So many things have been said already, and yet we believe that the sudden rise of AI generates many problems which are not apparent to the public eye and need to be discussed. And some of them are as follows: AI systems as ethical agent. In what way AI, which is able to produce text, is able to generate some procedures and ways of acting, can be treated as a human, as an ethical agent? How can it be held responsible, and what are the limits of this responsibility? The impact of AI on human life, of course, so I would say a sociological dimension to it as well, but also legal context of AI functioning. So what are the different kinds of legal and ethical regulations AI systems shall be subjected to? All different aspects of human AI interactions, how human and AI agents create groups, that will be presented in a moment, and also AI environmental impact. This and many other issues were the reason for organizing the CFP, writing a CFP, and then inviting all of you to send your submissions. I have to admit that the process for creating this issue is longer than usual, because I have to say we have rejected so far around 3 or 4 submissions, of course not yours, but 3 or 4 earlier submissions, which we found lacking. We have also accepted a similar number, and similar 3 or 4 articles have undergone a peer review process successfully. So right now we have the first group of articles ready for publishing in the issue, but we are working on the second group, on the second batch of articles, and your articles constitute that second promising batch. So we are confident, we are hopeful that the pre-review process will end up successfully, but in the meantime, we just want you to share your ideas, the inspirations behind creating your articles, and also the conclusions that you drew on the basis of the analysis in your texts. So without further ado, I would like to ask Max Parks, who has prepared the article, A Philosophical Account of Shared Autonomy and Moral Agency in Human AI Teams. So the topic that I mentioned before. Max, I would be very grateful if you launch your presentation. It can be either by sharing a screen or by just talking, and we are all ears.
Thank you. Give me just a second to start screen sharing. Okay. Apologies for the delay there. So I'm working on a master's degree in computer science at U of M Flint. I already have a PhD in philosophy. And so I'm approaching this topic from that interdisciplinary perspective. And with the guidance and assistance of my advisor, Mark Allison, we've been talking about, amongst other things, ethical frameworks for really exploring different issues, especially within social robotics. We've also done a bit on shared autonomy in human robot teams. For example, search and rescue missions can be conducted more efficiently if the human team members' mental states are taken into account to adapt for the autonomy levels of the robotic team. For example, when a team member has been, a human team member has been navigating a search and rescue mission for over 24 hours, that human ends up becoming fatigued and the whole team will work more efficiently if the robots become more autonomous. So within that context of shared autonomy and adaptive autonomy levels, we were thinking about to what extent are these different AI systems that we're using moral agents? And yeah, we tried to really get at the heart of this issue, although there's more work to be done, obviously. Okay, so the one of the main problems that we talked about was how can we responsibly integrate AI into morally significant domains? We started off talking about the trolley problem because that's sort of a low-hanging fruit, and it's very obviously at the intersection of philosophy and computer science when you talk about the trolley problem within autonomous vehicles. So this is a situation in which, yeah, we have to evaluate whether or not this AI system does the right thing. But with AI systems, they're really just following, at this stage, how we program them to act. So although we end up concluding that AI systems can genuinely participate in moral decision-making, moral responsibility, given the current infrastructure and design of AI systems, they cannot be morally responsible. Okay, so classic trolley problem. Yeah, I'm guessing most of you are familiar with this, but just as a sort of background, if there's a runaway trolley in the classic problem, is it morally better for someone to take an action that will result in some negative consequences, but it will be a lower level of negative consequences than if no action is taken by the bystander? Similarly, in the context of autonomous vehicles, if there's an inevitable accident or collision with either another vehicle or a group of pedestrians or a tree, how should the autonomous vehicle act, morally speaking? Should it protect the driver? Should it protect the pedestrians? What values should be prioritized and guide the behavior of the autonomous vehicle? What's the right way for it to act? We can ask all of these questions, but again, the end goal here is trying to figure out to what extent these systems really are engaging in moral agency. And even though they offer computational augmentation of our ability to evaluate complex scenarios, ultimately the responsibility lies with in AI, again, given the current state of things, the people who are programming it, the people who are interacting with it and making the decisions. For example, the driver is included in these scenarios, but ultimately the moral responsibility rests with the humans involved. And sometimes that's just more than one person. Okay. So right now, AI excels at calculations. A separate project I'm working on over the summer is developing a really high quality emotional intelligence benchmark. But right now, AI isn't great at emotional intelligence. It is really good in many domains at reasoning, although you can still stump AI models with complex second order predicate logic problems. So still has some work to be done. But regardless, apologies. Again, AI lacks the ability to have any kind of understanding of the consequences of the actions that are being performed. It doesn't have moral understanding or social understanding. Problems with evaluating how it should act and what role it should play in these calculations, that is, what role should AI be playing, is complicated by the fact that it's not clear how we should evaluate the moral status of actions within the original trolley problem. So, yeah, when it comes to the autonomous vehicles scenario, it's even less clear how these vehicles should act, what's the right standard, and what role, again, should the AI system be playing. It's going to differ from moral theory to moral theory. Now, again, the traditional notion of agency focuses on human rational deliberation and intentionality. In my dissertation for my PhD in philosophy, I focused on the relationship between cognition and phenomenal states. And I argue that you can have intelligence without phenomenal states. But in this context, I think there's something to be said about not having moral agency without at least some level of self-awareness so that you're aware of the consequences of your own actions to some extent. And right now, AI just doesn't have that, or it doesn't seem to. How to evaluate that is a tricky issue, but I suggest that we can break down the different aspects of moral agency and figure out what aspects AI can have. It can contribute to rationally deliberating about the different possible courses of action and the likely consequences. It can absolutely help us to make those decisions ourselves because it can maybe better inform us about the possible outcomes. But ultimately, the responsibility lies with humans because we have to evaluate those different possible outcomes, assign different values to those, and decide how to use AI to interact in a morally responsible way. Part of what this paper calls for is humans getting better in terms of understanding how to use AI. So we shouldn't just use AI to fill all of the possible roles that it can fill. For example, someone that I was doing jujitsu with was really excited about the possibility of sex robots. And yeah, didn't even care about possible relationships with humans anymore because this was the gold standard for this person. And that was what motivated me to start talking about this particular paper, actually, was thinking that that person had it wrong to focus on this as the end goal for human AI relationships. No, we should use AI to help facilitate developing our abilities to interact with other humans and be morally good people. And yeah, so moral agency, again, can be augmented by AI, but the moral responsibility ultimately rests rather with us. And it's then our responsibility to make sure that other humans using this technology are able to understand it. So we should use user-friendly user interfaces and among other things, yeah, just continue to use it responsibly and not aim to just have AI take over everything from writing papers, doing research within those papers, which I absolutely tell my students, don't let it do your research for you. You have to think for yourself. You can use this as a supplemental kind of aid to help you maybe in your writing or in the case of QT robots in developing social skills. But interacting with the robot itself isn't the end goal. Instead, it's to facilitate better human interactions. So I tried to not take up too much time. I know these are supposed to be really brief presentations, but yeah, I think some of the future direction in this area is potentially figuring out a standardized benchmark framework for moral agency. Again, in some of my other work, I break down mental states into the different related capacities that are associated with that mental state, for example, imagination, and figure out what aspects of that AI can have. I think that there's something that can be done with moral agency here, because as AI continues to progress and make advancements, maybe it can play more of a role beyond just cold, blind, rational calculations of consequences. And maybe as it becomes more emotionally intelligent, it can aid our moral judgments in other ways. So yeah, my final thought here is effective AI-human collaboration depends on enhancing human moral agency, but not replacing it.
Thank you very much. I think it was a very interesting presentation. Do any of you have any questions concerning the article written by Max? There is a question. Mr. Brian Paul, would you like?
Yeah. Hey, Max, thanks for that. Very interesting. It's in a way maybe more of a comment than a question, but I thought the analysis you gave of why it is that AI systems, at least currently, can't be moral agents, right? Basically because they're not yet moral patients, and that's really crucial for moral agents. You need to have some awareness from your own case, perhaps, or of what the consequences on sentient beings are of your actions in order to engage in moral reasoning and decision making. Seemed right. I wondered maybe if you could expand a little bit further on that, because I think it's a deeply important point.
I'm sorry, I didn't catch the very end of that, but I think you were asking about incorporating an explicit evaluation of whether or not AI can be considered moral patients into the broader context of this argument. I might have misunderstood.
Just if you wanted to expand on the argument that appeals to the lack of moral patiency, basically, or the lack of sentience, in making the case that current AI agents lack moral agency.
I do like this angle, and part of my paper again talks about how we as humans should try to better understand AI to facilitate our interactions, achieving the goals that we want us to achieve. But I think talking about it in the language of being a moral patient would be helpful in really hammering out the fine-grained details here. So thank you for that.
Thank you so much. Are there any questions? Any other questions? Okay, so if not, then thank you very much, Max, for your presentation. And now allow me to introduce the presentation on the article Computational Analysis for Philosophical Education, a case study in AI ethics. And that article, I believe, has been written by a group of authors, right? And that group has come to the webinar to talk about their text. So without further ado, I don't know what is your plan? How will you divide the content between you? But I believe that it will be a very interesting presentation as well. So please.
Thanks so much, Filip. So this is joint work, actually, not just of the other three faces you see in the screen here, Alice and David, myself, but a couple of other co-authors who are not here. I'm going to try to share my screen, and basically I will start, and then I'll pass over to David to carry on. But also Alice is here to, to answer questions. And then the co-authors who are absent are Alex Klein, who's a computer science colleague at, academic at Queen Mary University London, and Kevin Loy-Heng, a student, a research assistant who was a former student of ours. So we're pleased to be working with him on this. I should also say this is work that we've undertaken with some internal funding from Northeastern University, and so we're grateful for that support. And let me, without further ado, launch in. So our question basically is, what can computational methods, and particularly AI, tell us about AI ethics? This question arises in a context where we're doing a lot of AI ethics teaching in our programs at Northeastern University London. In particular, we have these two master's level programs. One is an MA in philosophy and artificial intelligence, and the second is an MSc in AI and ethics. And our aim in these programs is to provide philosophical and computational education simultaneously to equip students with the skills that they need to responsibly engage with AI technology, right? So we kind of think that you can't properly understand some of the issues in AI ethics without actually having a glimpse, a sense of what lies under the hood in these technologies. So we want to make sure that people engage both philosophically and computationally. And given that ethos, we thought it would behoove us to turn the use of computational methodologies on our own practice as educators by investigating some of the philosophy courses on those programs. So in particular, in order to test our thought that these computational tools can be useful for pedagogical and philosophical goals, we undertook a computational analysis of texts that we set on to our students on a couple of different courses on these programs. So one is a course on AI and data ethics, and the second is a course on advanced topics in responsible AI. And we labeled this our canon analysis. It's a little bit, overblown as a title for what we're doing. The text for the courses were chosen so that our students will have covered a variety of classic and current topics in AI ethics and in responsible AI, and not for the purposes of to serve as a canon for the field. But in any case, we needed a label, so we've gone with canon for this corpus of texts. And having gathered these texts, we've then used some standard Python-based natural language processing techniques to analyze the texts that lie within this body of work. So the first tool that we used is pretty straightforward. We just used a word frequency counter. So that allowed us to identify the words that appear most frequently in our collection of papers, and we've generated the word cloud that you can see on the screen with larger words indicating higher frequency in the corpus. And to our surprise, human was the most frequently used word across the text on these two courses. You can see data or datum there as well as pretty high, but we sort of conjecture that maybe people who are authoring in this area feel the need to contrast the technological systems and the data that they deploy with human beings. So that's the first kind of piece of analysis we did, but we then went a little further and we ran what's called a TF-IDF analysis. That's term frequency inverse document frequency. Basically that's used in typical cases to evaluate the relative importance of a word in a document compared to its importance in a corpus as a whole. We wanted to know about the relative importance of a word in the canon compared to some other corpus. we ran a conference at Northeastern University London in 2022 on Wittgenstein and artificial intelligence. And Alice and I and a former colleague, Alessandro Rossi, published a double volume on that topic just back in November. So because of all that work, we had a body of papers that we accessed through JSTOR discussing the work of Wittgenstein, and we used that as our kind of comparison corpus. So we have on the one hand the canon from AI ethics, and on the other hand some Wittgenstein scholarship and work as a comparison corpus. And the image here is actually image that was generated as we were working on the Wittgenstein and AI double volume. We used AI to generate images of various things, including we tried to do Wittgenstein duck rabbit, and we got this somewhat amusing image as the output from that. So we didn't use that in our book. So when we did this comparative analysis, it turned out that human is not just the most frequent unique word in the canon, but it's actually particularly important in the AI ethics papers compared to the works discussing Wittgenstein, right? So in the little chart on the slide, you can see the top 10 words by relative frequency in the AI ethic canon, and on the right, the top 10 words by relative frequency in the Wittgenstein corpus. And so human stays at the top relative to the Wittgenstein corpus within the canon, but also we got some confirmation that our analysis is working appropriately because Wittgenstein came up as the second most common word, relatively speaking, the second most relatively frequent word in the Wittgenstein corpus. So, so I think at this point I'm going to hand over to David. And so I'll stop sharing my screen and let him pick up with the remaining, and where we really begin to use AI actually in our analysis.
Okay, great. So let me share this, and okay, can everyone see that clearly? Yep.
It's not yet. Oh, yeah.
Oh,
Now
yeah.
it's full.
Oh, okay. Yeah, there's just a lag then. Okay. So the next model we started using was more a machine learning type of thing, where we decided to use transformer models to measure the semantic similarities between papers. So in particular, we applied Cybert, a well-used transformer model that's trained on scientific texts in particular, which converts papers into high-dimensional vector embeddings. And then once we have these numerical representations of each paper, we can compare their semantic similarity using particular metric, in this case, it's a cosine similarity score, which tells us how semantically similar the content of two papers are to each other. So essentially, the higher the semantic, the more similar the semantic content of the two papers, the closer together their vectors are going to be. And using this measure, we attempted to draw out where papers in our canon were grouped together around different subjects, topics, and themes. So once we had these semantic similarities, these vector representations of papers in a higher dimensional space, we applied clustering algorithms, in particular k-means clustering, to group papers into clusters based on how semantically similar different papers are. Now, of course, you can test for different numbers of clustering, of clusters that could appear in the group. And we tested many different numbers, and eventually we opted for 6 clusters, which gave a general good trade-off between better representing the data and using more clusters. Of course, the more clusters you have, the better those clusters can overall represent the data, but you might want a simpler representation that doesn't have as many clusters. And we went for 6. And then to visualize the clusters, we flattened these vectors from a high dimensional, a 768 dimensional space, which is given by the Seibert embeddings, into just a 2-dimensional space using principal components analysis. So that's something that we can actually see and visualize as human beings. So here are some visual representations of the canon of papers clustered into different numbers of clusters, and then flattened, as I say, using principal components into 2 dimensions. So here we have on the top left, we just have 1 cluster, and then the number of clusters gradually increases. Now you can see that as the number of clusters increases, it looks like there's a lot of overlap between the clusters. Of course, this is an artifact of the fact that we flattened the data from what was 768 dimensions into just 2. And so clusters that can be kind of over the top of each other in the higher dimensional space, but still separated in another dimension, might start to overlap when we condense that down into just a few clusters. And here you can see quite clearly 6 seems to be a fairly reasonable and clear number of clusters, both visually as well as according to different metrics of clustering. So when we looked at which papers fell into each cluster, though, we had a fairly hard time interpreting the clusters. We couldn't clearly determine clear topics in AI ethics that seemed to correspond nicely to each cluster. And we think this was due to 2 reasons. First, the high dimensionality of the data. As I say, it was in 768 dimensions, and many clustering algorithms, including k-means, just struggle with very, very high dimensional data like that. And then also the relatively small number of papers used within our analysis, around 200 papers, roughly speaking. And so many papers also engage with overlapping topics. And of course, k-means as a clustering algorithm, when it tries to look for clusters, looks for clusters that are neatly separated and exclusive. And this isn't necessarily the case with our analysis of AI papers. Many papers kind of cross over many different topics. That's obviously going to be the case, for example, with review papers, but also many papers kind of wander between or draw connections between 2 different topics anyway. And so we tried an alternative method for grouping the papers in our canon. So we next used another machine learning technique called latent Dirichlet allocation, or LDA, which is a form of topic modeling to analyze the canon. Now, LDA is in some ways a rather simpler algorithm as compared to the transformer model of Seibert, because LDA just treats each paper as an unordered collection of words, whereas the transformer model actually looks at the relative positions of each words and the semantic relations between them within sentences and groups of words. So it's a simpler model in many ways. We used LDA to gather the papers under topics and then to produce a list of words for each topic for making it more interpretable. And so for each paper, LDA gives us a probability that it falls into a given topic. And unlike the previous method, which, as I said, was exclusive, a paper doesn't just have to be assigned to one topic with LDA. Instead, it can have a high probability of concerning multiple different topics. And this may be for a good reason. For example, as we've said, an overview paper might end up having a high probability of concerning topics like privacy, AI design, and robot agency, all in one paper. So here's an overlap matrix of the different topics. We identified, again, 6 topic clusters. And here we're looking at the overlap between of papers that have a high probability of falling within 2 different topics. So the topic clusters that we identified, we roughly label as following. Topic 0 here refers to topics around social aspects, social media, gender, and culture as it relates to AI and information ethics. Topic 1 is topics around superintelligence, the singularity. Topic 2 are a kind of mix of different applied issues, including sustainability, AI and healthcare, AI and the arts. Topic 3 were topics around robots, personhood, and artificial agency. Topic 4 was around AI design and responsibility in AI. And then topic 5 were topics around privacy and risk. So as you can see, there's a lot of overlap between some of these topics and less overlap between others. In particular, topic 2, applied issues, is having a lot of overlap with social media, gender and culture. It's having a lot of overlap with topic 3 on robots, personhood and agency, and topic 4, design and responsibility. Whereas topic 5 on privacy and risk and topic 1 on superintelligence and the singularity are more isolated. They're not overlapping very much with the other topics in this cluster. And in fact, in general, I think there's quite a lot of overlap between topics 0, 2, and 3, and 4, whereas topic 1 and topic 5 are more separated out and more distinct from the other topics. So some reflections here. So first, we think philosophers have so far arguably failed to take full advantage of the opportunities that these type of computational methods afford us, and that are widely used already in some of the humanities. And we hope that this project, which is still at a starting point, provides one jumping off for showing how computational techniques can inform both philosophy and philosophical pedagogy. And we think it supports discovery and discussion where humans are working with AI tools, but there's still a lot of human interpretation that is going on here. The AI is doing some of the algorithmic work, the computationally heavy work, but then there's a huge element for human interpretation in understanding what these results actually tell us. And we think that these results highlight the potential of natural language processing in conceptual exploration. However, at least for our small data sets, surprisingly enough, we found that the relatively straightforward and simple bag of words technique was actually working better than the context-sensitive and more contemporary transformer approach. And so sometimes simplicity in this type of work is actually the best approach. Okay, so in terms of future directions, we plan to use the topics and semantic clusters to identify and analyze a much larger AI corpus in both computer science papers, which we're getting from the archive repository of preprints, and philosophy papers, which we're getting from Phil Papers. And all in all, we have a larger corpus here of around 100,000 papers in each, which we think will hopefully be more amenable to clustering analysis, but will also be amenable to the LDA topic modeling approach as well. We plan to build a larger semantic map of the AI ethics landscape. So there's an example here of a similar type of landscape, which contains around 3,000 papers. So we think that we have the computational capabilities to conduct an analysis very similar to this, but on a larger body of perhaps up to around 200,000 papers. And further analysis here is likely to deploy network analytics as well, perhaps involving citation and co-authorship data alongside topic networks. So yeah, thank you very much.
Thank you both for a very thorough, interesting presentation. Multi-dimensional, I would say. The article is definitely well thought. Max, do you have any questions or reflections as to the article?
I thought there was a fair bit of overlap, especially with your focus on human interpretation and using that along with the computational ability of AI. So yeah, I thought there was a lot of overlap between our projects. I don't think I have any questions, although I'm excited for your paper to be published so I can go through and read through the details and find out more.
Great. I can tell you that we expect the second reviews of both of your articles to be received by the end of the month. And as you see, it's almost the end of the month. So I'm really hopeful that I will be able to send them to you in just a few days. That's a very favorable scenario. And then you will probably have the next few weeks to revise the article. I'm hopeful about the results. Thank you very much for both of your presentations. I'm really looking forward to work with your texts further. And of course, after the pre-review process is complete, hopefully, The webinar will be published on the YouTube. I will just send you the information. If you don't have any questions to me or to you, then thank you very much. And I wish you a successful and joyful, peaceful holidays, summer holidays. Thank you.
You too. Thank you.
Thank you. It was a great pleasure to present. Thank you.
Thanks, Filip, and stay in touch.
Thank you.
Right. Bye.
Goodbye.